You know, we're always hearing about how AI is getting bigger and smarter and more powerful. But what if I told you they have this secret weakness? A kind of digital amnesia. Yeah. Today, we're diving into one of the most fascinating challenges in AI right now. How do you teach an old model new tricks without making it completely forget everything it already knows?
All right, let's break this down with a really simple question. Let's say you've got an AI that's a total pro at English. So you think, hey, let's teach it Korean. And it works. It becomes fluent. But then you ask it something in English, and it just gives you a blank stare. All that English knowledge? Poof, gone, overwritten. And this isn't some sci-fi scenario, you guys. This is a very, very real problem. So, yeah, this thing actually has a name in the AI world, and it sounds just as bad as it is. Catastrophic forgetting. Seriously, it's one of the single biggest roadblocks we have to creating AI that can actually keep learning, like we do. I mean, think about it. If every time an AI learns a new skill, it risks basically wiping its own memory, how is it ever supposed to build up a real deep understanding of anything?
And this really gets to the heart of a huge problem in AI development right now. See, for years, the go-to strategy has been pretty simple. Just make them bigger. More parameters, more data, just throw more computing power at it. But that whole approach, it's starting to hit a wall.
And don't just take my word for it. Check out this quote. This is directly from the researchers whose paper we're looking at today. They're basically sounding the alarm, saying what a lot of people in the field are quietly admitting. The era of easy wins just by making models bigger, well, it's coming to an end. We can't just brute force our way out of this one. We have to get smarter.
Okay, so if just make it bigger isn't the answer anymore, then what is? Well, the research points to this kind of fork in the road. There are two main ways to grow an AI's brain, and believe me, they have wildly different results when it comes to memory.
So on one side, you've got what's called depth upscaling. The best way to think about this is like building a skyscraper. You're just adding more and more floors, making the model taller and its thinking process deeper. Then on the other side, you have width upscaling. This is more like adding new lanes to a highway. You aren't making the journey longer, you're just making the road itself wider so more traffic can get through at once. And trust me, this difference is everything.
Okay, and this chart just perfectly illustrates the problem we're talking about. It's looking at two things. Adaptation, that's how well a model learns new stuff, and preservation, how well it hangs on to the old stuff. Now look at Llama Pro. That's a depth method, the skyscraper one. It's fantastic at adapting, right? But its preservation score? Oof, it's in the basement. It learns the new thing by basically demolishing the old thing. That is catastrophic forgetting, right there on a chart. But then, look at this other method, scale. It's killing it on both. So what's its secret?
And that brings us to the star of today's show, the scale method. It's short for Upscaled Continual Learning, which is a mouthful, but the important part is that it's a completely new width upscaling architecture. It was designed from the ground up for one reason, to solve this exact memory problem. It's a whole new way to expand an AI's mind without the amnesia.
So how does it work? Well, here's the magic trick. It takes the original, fully trained model and basically puts it on ice. It freezes all of the original parts. Nothing in there can be changed. Then, it very cleverly slips in these new, lightweight expansion blocks right alongside the old parts. So you're adding room for new knowledge, but you're not messing with the core foundation at all.
And this diagram from the paper shows you exactly what I'm talking about. See that big block? That's the original model, totally frozen. And those smaller, colored blocks? Those are the new trainable parts that Scale slots in. It's literally adding new lanes to the highway without ever having to shut down or tear up the original road.
You can honestly boil the whole thing down to a super simple three-step process. Step 1, you freeze the original model. Just lock it down, protecting everything it knows. Step 2, you plug in these new lightweight expansion blocks. And step 3, when it's time to learn something new, you only train those new blocks. The original model just sits there, acting as this super stable, all-knowing foundation.
Now, the researchers who came up with Scale based it on two really cool core principles. And I love the names they gave them. You can really think of it as this perfect balance between fire and ice.
So on one side, you have the ice. That's persistent preservation. Its whole job is to freeze and protect all that old knowledge. And on the other side, you have the fire, collaborative adaptation. This is what forges all the new skills. And it's that perfect balance, the dance between the fire and the ice, that lets the AI learn new things without just melting away its past.
So let's drill down on that ice part, persistent preservation. By literally freezing the original model's programming, its weights, you're guaranteeing that its core skills stay 100% intact.
It doesn't matter what new stuff you throw at it, that original knowledge base is completely safe, just locked in place.
And then you have the fire, the collaborative adaptation. This is where the action is. Those new expansion blocks are the only things that get trained on the new data, and the key word here is collaborative. They learn how to work with the frozen original model to build new skills, not replace the old ones.
All right, so the theory sounds amazing, right? Fire and ice, it's all very poetic. But the big question is, does it actually work in the real world? Well, the researchers put Scout through its paces with some really tough tests to find out.
So for the first big test, they used what's called a biography dataset. First, they taught the AI a bunch of facts about 50,000 different people. We'll call that task 0. Then they taught it about a brand new group of 20,000 people. That's task 1. So the million-dollar question is, after it learns all about that second group, does it still remember anything about the first 50,000?
And wow, just look at these results. This is for that skyscraper method, Llama Pro. The blue line is how well it remembered the first group of people. And look what happens. The second it starts learning about the new group, its memory just falls off a cliff. I mean, it drops all the way down to 15% accuracy. That's not just forgetting, that's a total system meltdown. A textbook case of catastrophic forgetting.
Okay, but now let's look at scale. I mean, the difference is just night and day. Check out that blue line again. Its accuracy on the original task, it barely moves. It stays incredibly high. And at the exact same time, that orange line shows it's learning the new task perfectly. This is the holy grail. This is what it's supposed to look like. Learning without the forgetting. All right, so the second test takes us right back to where we started, with the language learning idea. They took a model that was an expert in English and then started training it on a massive amount of Korean text. This table basically shows how much English it remembered afterwards. Higher score means less forgetting. So Llama Pro, its English score dropped down to about 44.5. But Scale Root, that's a version of Scale, finished with a score over 46. It just did a better job of holding on to its English while learning Korean.
Okay, so let's zoom out for a second. What does all of this mean for the future, for the big picture of AI? Well, this research is pointing to a really fundamental shift in how we need to think about making AI better.
And here's the bottom line, the most important takeaway. The future of AI is not just about making them bigger. It's about making them smarter. It's about clever architecture. A method like Scale proves that a really thoughtful design can solve huge, fundamental problems that just throwing more power at it never will.
So why does this matter to you? Well, because this is what opens the door to AIs that can actually learn continuously their whole lives, kind of like we do. It's so much more efficient than having to retrain a massive model from scratch every time you want to teach it something new. It means we can have an AI that specializes in, say, medicine without it forgetting how to speak basic English. At the end of the day, it's about building AI that is way more stable and way more reliable.
And that really leaves us with a pretty cool question to think about, doesn't it? We've seen that smart design can fix AI's amnesia. It proves the future isn't just about size, it's about being clever. So the real question becomes, what other brilliant designs are out there just waiting to be discovered? What's the next big idea that's going to help these machines learn and remember and grow a little bit more like us?